Okay, this is the most important measure of dispersion because before this we discuss range and quartile deviation. The range is the weakest of measure of dispersion that just gives us the boundary of the boundary of the data set. Like that's the difference between the maximum and minimum value of the data. While on other side we have quartile deviation. Quartile deviation is also a bit better than range, but since it is finding the difference between the two quartile, the first and the lowest and the highest quartile. So still we are leaving some values out of the box, like we are not including it in our calculation. Therefore, we need another measure of dispersion. We have mean deviation, but that's not into our discussion. It has also some good qualities, some bad, but the most perfect one we have is variance and standard deviation. Since both of them, they are very they are interrelated to each other. So first we'll discuss variance. Now, in variance, what is the variance? First, we'll define that. Now, this is the average of square deviation of each value from its arithmetic mean. Now, from the definition, you can conclude that average means that summation over n. Deviation square means the square is in the formula, okay, and then deviation means subtraction. Each value represent xi and arithmetic mean is x bar. So see, the first one is the formula for ungrouped data when we have to find the variance. Okay, the second is variance, which is equal to summation x square over n minus summation x over n whole square. Now in this we got what we have this second formula. Now this second formula is the derived formula. So now the question is why we have to formula for ungrouped data. So see, actually the first formula is the basic formula for understanding, but this first formula calculation is very difficult because first we have to write x values, then we have to find mean, we have to subtract that mean, we have to take those values, square, and then finally we sum up and then divide it by n. So that's quite a bit calculation. It requires lots of time. So we have another simple formula, which is summation x square over n minus summation over n. So that's the second important formula. Now so therefore for calculation purpose we'll use the second formula. So now the question is, how can we write the group data formula? Now see, so the group data formula will be as such. We have to only introduce summation f. After summation we'll introduce f, the rest of formula will be same. And if we are writing the derived form, so that will be summation fx square divided by summation f. As all of you know that n is always summation f in group data. So the other part is that summation fx divided by summation f. One point you have to remember, that see this square part in the derived formula, summation x over n, that's mean x bar without x square. Okay, similarly in the group data, summation fx over summation f, that's again mean, arithmetic mean. So we have to include these into our calculation. Now check what sort of questions we may have for ungrouped data, and then we'll solve questions for group data. Now one can check that we have, this is a question for ungrouped data, that find the variance, standard deviation and coefficient of variation for the given set of data. Why I am adding standard deviation and coefficient of variation, I'll explain it later. But first see, this is an ungrouped data. We have observation 5, 8, 11, 13, 9, 6, 12, 4, 13 and 19. Now the first thing is that if we use the first formula, so it will be a lot more difficult. So I told you we'll be using the second formula, the derived formula for variance. Okay, you have to check. So for that you only need these two columns. X you will write and x square you will find. 5 square is 25, 8 square is 64, 11, 121 and so on, and finally find the sum. Okay, there is one another thing that is that you have a built-in function in calculator. So I have recorded a separate value for that, where you can just put these x values into calculator, and then you can directly find mean, standard deviation, sum of x square, and sum of x, okay, with just one click. So I have recorded that, so I'll also upload that video. That will help you. But see, remember, that is only for ungrouped data. So you, if in exam, like suppose if I give you question in objectives, so if there are only values, so you can just directly put it in the calculator and get variance, standard deviation, and all these sum of squares. Okay, so that will be quite helpful. So I'll be adding that. Now see, variance of x square, variance of x is equal to summation x square over n minus summation x over n whole square. Now summation x square is 1186, total number of observation is 10. Similarly, summation x is 100, total number of observation is 10. So the calculation is 118.6 minus 10 square. Now inside this bracket, this 10 is mean. If you can check, I told you before that summation x over n is mean. So now 118.6 minus 100 is equal to 18.6. Now standard deviation of what is standard deviation? What is the relationship? So that is just the square root of variance. Similarly, variance and standard deviation, so standard deviation will be the square of variance, and vice versa. Okay. Similarly, so now we got 18.6. So 18.6 is under the root 43.13. That's sorry, 4.313. That's the square root of variance, which is called standard deviation. Now what's the other last thing? That is coefficient of variation. Its formula is the same, standard deviation divided by mean multiplied 100. But see, the standard deviation is 4.3.